This conference will now be recorded.
Hello everyone. Today also we will continue nomenclature of organic compounds and we'll start with some problems based on the discussion that we have already done. Okay. And once we have finished this, after that we will start nomenclature for aromatic compounds. Fine. So here the question that we have first. The correct IUPAC name we have to find the structure of the molecule that is already given, and there are total 4 options. We have to choose the correct name. Here, if we look at these molecules, first of all, we have to find the longest chain, which will be our parent chain. And here we have two groups. One is carbonyl group, C double bond O. Another one is CO2H. Now, among these two, we will give priority to CO2H. Fine. So numbering will be starting from CO2H because that functional group must be present in the parent chain. So if I am starting here 1, then 2, 3, 4, 5 and 6. So at 5 position now we have C double bond O. And we also have one more substituents which is present at 2 positions. Fine. And in the parent chain, total number of carbon atoms 6. That means the root word that we will use, it will be hex. Though hex is present in all the options, so based on which we cannot decide anything. But see, as there is CO2H, so the name will end with oic acid. Now oic acid is present in all the options, right? So that is also not correct. Next thing what we have to do, we have methyl substituents and also one more substituents, that is, though it is functional group, but here it is not the main functional group. Main functional group is CO2H. So at 2 position there is methyl, but at 5 position there is oxo. So 2 position we have methyl, 5 position we have oxo. Now M will come before O alphabetically. So that is why the name will start with 2-methyl. Now 2-methyl is present only in option 2. So first there is 2-methyl mentioned, then it is 5-oxo and then hexanoic acid. Fine. So in hexane, E we have to omit and then just after N directly we have to write oic acid. So considering all these factors, we will choose this option as the correct option. 2-methyl 5-oxo. And why the other options are not correct? If you look at the other options, the first option it is starting with 5-formyl, but 5 position there is no formyl group. Formyl we use when there is CHO, but it is not CH, it is C double bond O. So 5-formyl it is not correct. Then 2-methyl it is okay, but 5-formyl is not correct. The formyl, that is the term formyl, should not be present in the name. That is why this option is also not correct. And why the last option? What is the problem? Here 2 position is methyl present, not 5 positions. Okay. Next question also, a structure is given and we have to find the name. Now in this structure we have only carbon and hydrogen and there is also unsaturation. So first thing that you have to do, you have to choose the parent chain. Now in the parent chain, there will be presence of CC double bond. So keeping the CC double bond, if we see, then the numbering will be starting from this side. 1, 2, 3. Now I will move to the left hand side. Now if I am continuing in the left hand side, then it is 5 and it is 6. But see, if I am continuing here, here also it is 5 and 6, right? But when it is, I am doing it in this way, then the substituents that I am getting, isopropyl, then we have at 5 position methyl and we have at 4 position ethyl. Suppose I am doing the numbering in a different way. Let me do it differently so that we can understand why this one is correct. So suppose I am numbering in this way, 1, 2, 3, 4, 5 and 6. Now see, there will be total 2 substituents, 2 isopropyl substituents. But in this case, we are getting more than 2 substituents, right? Total 3 substituents. So that is why this will be correct option. Now, what are the substituents we have? At 3 position we have isopropyl. I'm not writing the totally, I'm just writing iso, 3 position isopropyl. Then at 5 position we have methyl group. Then at 4 position we have ethyl group. Now if we see alphabetically, E will be should be mentioned at first, and then it should be I and then M. Okay, so at 4 position we have ethyl, and then we have isopropyl, and at 5 position we have methyl, and here in the longest chain we have total 6 carbon, so that is why word root will be hex, and as there is a double bond present, that means it will end with in. And what is the position of in? It is hex 1 in. Now hex 1 in, that you can find here, though these two are there is also present, but when it is mentioned at hex 1 in, it is not hexa hyphen 1 in, it is hex, hex, then 1, fine. But we also have to take care about the substituents. Substituent must be mentioned alphabetically. So ethyl should be first, then isopropyl, then methyl. So all these conditions are present in option C, so that is why this will be the correct option. So when it is isopropyl, it is already mentioned in the previous class that you have to consider this I. But it is not true for all the other substituents. Especially in this case, I should be considered, not P, when it is isopropyl group. Fine. So for ethyl, sorry, there will be L. For ethyl, then isopropyl, then methyl, because E, then I, and then M, and then hex 1. We'll go to next question. Here also we have structure given. Now in this case, some in the options E is mentioned, but see what is E and what is Z, that we haven't discussed it yet. It is basically we will see in once we know about different types of isomers, then only we can use this type of notation. But we don't have to think about it because all the options there is presence of capital E. So that is why we don't have to think about it. We'll just consider the rest of the part of the nomenclature. For E, there will not be any difference. Only for 4E and 2E is there, and that is because of at what position of the carbon the double bond is starting. E is basically used in case of when there is CC double bond, whether it is that is high priority groups are on the same side or not, but that will be discussed separately, not here. We will not focus on E because that is present in all the options. Now in this molecule we have simultaneous presence of C double bond O, and also there is C triple bond C. Sorry, C triple double bond C, C triple bond C. Both type of unsaturation is there. So this is in and this is I, right? Now we have seen in the last class that when their positions are equivalent, what I am trying to say by equivalent, suppose if you are starting the numbering from this side, it is 1 2. If you are starting the numbering from the other side, that is also 1 2. That means these two are present at equivalent position, and when they are present at equivalent position, you have to give lowest number to CC double bond. That is the rule. Okay, so that is why the second numbering we will reject, the first numbering, that is actually the correct numbering. Now if we are moving in this direction, it is 3, then it is 4, it is 5, and it is 6. So in the parent chain we have total 6 carbon. So word root is hex, but that is present in all the options, so based on that we can't do anything. Now the position of YNE, that position of YNE is 4, and position of in is 2. So it must be 2 in 4 in. So if that is the case, these two should not be correct. Now if it is hex 2 in 4 in, both are same. Okay. Now how to reject any, that is among 3 and 4, how we will reject one of them? 2 bromo and 5 bromo. Now in our case it is, there is a bromine substituent is present at 2 positions, so that is why third option would be the correct option. Okay, 2 bromo, hex 2 in, and then 4 in. Again we have structure. In this case we have fluorine, we have OH, we have bromine. So we have halogen as well as we have hydroxy. Now when we will choose the parent chain, we will try to see all of these are present in that chain, and there is actually only one option. Now the next question arises that what is the direction from which you will start? Now suppose I am numbering from this side. So it will be 1, 2, 3, 4, 5, 6. So what root is 6 carbon, that is hex. But if I am following the other possibility, then what will be the position? See, 1, 2, 3, 4, 5, 6. So in the first case, the positions are, that is the substituents or functional group, they are present at one position, which is for bromine. Now at that is I am following the purple numbering. At 3 position there is OH. Then at 4 position there is methyl group. Then at 2 position there is Cl. So it is 1, 3, sorry, it is 5. Just follow the purple numbering. According to that, these are the positions 1, 3, 4, and 5. But if I am following the green one, now at 2 position there is chlorine, at 3 position there is methyl, then at 4 position there is OH, and at 6 position there is Br. If we follow the first point of difference rule, then obviously 1, 3, 4, 5 should be better. But here even that rule you don't have to consider, because here we have functional group OH. So based on that you have to decide mainly. Now if it matches with the first rule of first point of difference, it is fine. If it is not matching, then also you have to give preference to the functional group. Okay, so that numbering you should follow, where OH group is getting lowest number. So that is why it should be 3 position, right? Now if that is the case, that means bromine is present at 1 position. So the second one we will cancel. We have to follow the first one. So at 4 position, now we have methyl group, 5 position we have chloro. Now total 3 substituents are there. Among these, B will be getting preference, which is for bromo, and after that we have chloro. After B there will be C, and after that there will be methyl. Now for bromine, the position is 1. For chlorine, the position is 5. For methyl, the position is 4. So it must be 1 bromo, 5 chloro, 4 methyl, and then it is hexane 4 all. Fine. So it is matching with this last option. Okay. So first of all, these two, it is not correct, because it has to be 3 all. OH should be given lowest number, whether it is matching with the rule of first point of difference or not. Irrespective of that, you have to give preference to this. So that is why this is the correct option. And here we are accepting the purple numbering. This is the correct numbering. Okay. Here name is given and you have to choose the correct structure, right? So first we will draw the structure on the basis of the name that is given. Now in the name, your first focus should be on the word root, which is hex. Now if it is hex, that means total 6 carbon you can draw. Now if that is the case, let me draw 6 carbon. Now at 5 position, there is YN. So that is why I have directly drawn the C triple bond C. Now after 5, it will be 6. Sorry, 1 is not there. So it is ending at this position. And 3 position, there is in. So I will put CC double bond here. Then at 4 position, we have methyl group. And 3 position also there is ethynyl. Now what is ethynyl? Ethynyl is combination of eth and in, and as it is treated as substituent, so that is it is ending with YL. It is nothing but C triple bond C. Okay, so at 3 position we will have 2 carbon substituents, but it is CC triple bond. Okay, and hydroxy OH. And the main functional group here is oic acid, which is COOH. And it should be, and based on this, the numbering is done. You have to give preference to CO2H, not OH. OH should be treated as substituent. So that is why there is no all. There is hydroxy. And as it is ending with oic acid, so numbering should be like this. So CO2H carbon is getting number 1. Now we have to see with which structure it is actually matching. Now for that you can, if you want, you can slightly rotate the molecule so that you can easily understand it is matching with which, but without doing that also you can do. You just have to compare the structure. So the carbon with which CO2H is attached, same carbon, there is also OH attached, but that is present in all the options. Now to the next carbon, after the OH group bearing, there is CC double bond. And that is also present in all the structure, right? Now after that, there is methyl substituents, not ethyl. That you can get here and here. Fine. And then we have at 3 position. Now if I'm numbering it like this, 1, 2, 3, 4, 5. And if I'm numbering this, because A and B not possible, there is no methyl substituents. That is why we can cancel that. 3, 4, 5. Now see, at 3 position there is methyl substituents, but in our case at 3 position there is ethynyl substituents, right? Sorry, there's a little mistake I have done. 1, 2, 3. 1, 2, 3. 4, 5, 6, because it is hex. 3, 4, 5, 6. Now, if we compare with our structure, basically you will find here 3 position methyl, but here 3 position ethynyl. But in our case, 3 position there is ethynyl, 4 position there is methyl. So it is actually matching with D. But if you want, you can also rotate the structure. As you can see, you can also draw the, you can change the structure like this so that you can compare with the structure given in the options. That is up to you, whichever way you like it. Fine. So option D will be the correct option. So whenever a name is given, you have to focus on the what root, then look at the functional groups, and after that see whether there is any unsaturation present or not in the parent chain. Then you can consider the substituents. So here we have ethynyl at 3 position, we have OH group at 2 position, we have methyl group at 4 position. So total 3 substituents are there. Total 3 substituents. This is not substituent because it is part of the parent chain. And parent chain, I can highlight it like this. This is parent chain, okay? Total 3 substituents. Option D is the correct option. The IUPAC name of the following compound. Here we have only carbon and hydrogen. This is basically hydrocarbon. And as there is CC triple bond and CC double bond, both are present. So we have to choose the parent chain in such a way, we'll try to keep this unsaturation. Now, whether to start the numbering from this side or this side. See, here, when both these different types of unsaturation, that is triple bond, double bond, both are present simultaneously, and if their positions are equivalent. Equivalent means if you are starting the numbering from double bond, then also it is number 1. If you are starting from CC triple bond, then also it is number 1. So when we have equivalent positions for these two different types of unsaturation, you have to give lowest number to CC double bond. So that is why it must be 1 in, and if it is 1, then 2, 3, 4, 5, 6, 7. So it is 6YNE, not the other way. Now consider the substituents. We have substituents methyl at 3 position. We have substituents propyl at 4 positions. We have another methyl substituents at 5 position. Now methyl and propyl, you have to give preference to methyl, and you have 2 methyl substituent at 3 position and 5 position, and the longest chain is containing total 7 carbon. So it must be hept and ending with 1 in 6 ine. So after hept, it is 1 in 6 ine, but don't make the mistake. Always put in before YNE. Whatever is the position of in. Here it is 1, that is fine. But suppose even if it is higher number than triple bond, then also it should be before, because of the alphabetical order. So first it should be 3,5-dimethyl. This is number 1 substituent, second substituent, third substituent. So 1,3,5-dimethyl, first substituent, second substituent. Then 4-propyl, hept 1 in 6 ine, and that is matching with option D. Okay. See why the first option is not correct, because in the first option the numbering is not correct. If you are following numbering from CC triple bond, then option A is correct. But in option A, we cannot choose it correct, because we have to give lowest number to in, not ine, because their positions are equivalent. If their positions are not equivalent, you have to follow the rule of first point of difference. Otherwise, if their positions are equivalent, lowest number should be given to CC double bond. Fine. So option D is the correct option. Next molecule is this one. Now you can see the difference. In this molecule also, simultaneously there is presence of CC double bond and CC triple bond. Right. Now if I am starting the numbering from this side, then double bond will get number 2. But if I am starting from right hand side, then double bond will get very high number. That means here CC double bond and triple bond, their positions not equivalent. So when their positions are not equivalent, we have to consider the rule of first point of difference. Now if you are starting the numbering from this side, then it is 1, 2, 3, 4, 5, 6, 7. So it is hept, that is fine, and that is present in all these options. And look at the positions. It is 1, then 4 position there is ethyl, 5 position there is methyl, 5 position there is also double bond, and 6 position there is Cl, chlorine. And if I am following the numbering from left hand side, then it will be 1, 2. So the first substituent is getting position number, not substituent, I mean to say the first numbering, it is locant is 2. So that is not right. According to rule of first point of difference, it should be lowest. So that is why the other numbering, that is the left hand side numbering, left hand side to right hand, that I am rejecting. This is not right. Now we have total 3 different substituents. We have methyl, we have ethyl, and we have chloro. Now chloro should be at first position because it is C, then it is E, and then it is M for methyl. Chloro, ethyl, methyl. And it is hept. And after hept, it should be in, and then it should be ine. But in is at 5 position. In is at 5 position. Ine is at 1 position. So 5 in, 1 ine, and 6 chloro. Ethyl is at 4, methyl is at 5. So everything is matching with this option, first option, right? So that is why this should be correct. Now look at the other options why it is not correct. If you are considering the second option, in this point, up to this point, there is no problem. The problem is here. Wine is mentioned before in. That is not correct. It should be here because of the alphabetical order. What is the problem with the second and third? Third and fourth. The third and fourth is the numbering starting from left hand side. So that is why this is not correct. C and D not correct because here left hand side numbering is followed. A and B right hand side numbering is followed. But why we are rejecting B? Because of this wrong alphabetical order. Fine. Now we have cyclic compound, and in this case we have OH group and the main ring, that is actually sorry, write it clearly. Cyclohexane, but we have OH group and we also have 2-methyl. Obviously, we have to give priority to OH. And if it is ending with all and there is cyclohexane, then it should be cyclohexanol. It should be ending like this. But we have to, as priority will be given to OH, so numbering should be from this side 1, 2, and 3. Don't follow the other direction. That is, if you are doing 1, 2, 3, 4, 5, then 5 position there will be 2-methyl, which is completely wrong. We have to follow the rule of first point of difference. So 1, 3, 3, it is better than 1, 2, 3, 4, that is rather than 1, 5, 5. So 1, 3, 3 is better. 1, 3, 3 better than 1, 5, 5. So that is why we are following it. And methyl you have to mention first, 3,3-dimethyl, then 1 cyclohexanol. Fine. Even if it is, we are not mentioning that it is 1 cyclohexanol, then also it will be correct. Just check if it is correct or not. Suppose you have already chosen an answer. Just forget about the structure and whatever nomenclature you have chosen, based on that try to draw the structure. If you are getting the same structure as it is mentioned in the question, that means nomenclature is right. Okay, so it will be 3,3-dimethyl 1 cyclohexanol. Sorry, it is wrongly mentioned here, not this one. This third one will be correct. Okay, this is not correct. So 3,3-dimethyl cyclohexanol, that should be correct. Fine. Now, as I have said, even if you are not mentioning the position of OL, then also it is correct. Because when you have already mentioned the position of methyl group, that means obviously the OH will be at 3 position. So even if we are not mentioning this one, then also we can say the nomenclature is fine. There is nothing wrong in that. Next question, we need the structure, right? So this is the structure. 1 minute. So here we have again 6-membered ring. And in this 6-membered ring, we have chlorine and we have bromine and we have also CC double bond, right? Now, if I am doing the numbering like this, let me do the numbering. That means at one position we have chloro, at one position we have CC double bond, and at 3 position we have bromine. If I am doing the other numbering so that we can understand why it is not correct. Suppose instead of moving towards this direction, if I am moving the other way, 1, 2, 3, 4, 5, then the numbering is 1, 1, 5. But in this case, it is 1, 1, 3. Because at one position Cl, at one position double bond, at 3 position Br. But if you are following the second one, why it is wrong? Because it is 1, 1, 5. At one position Cl, at one position double bond, but at 5 position Br. And there is one more reason also why this is not correct. Because as you have started the numbering from this position and double bond direction is towards this side, so you cannot move this direction. This is completely wrong. Even if you are getting whatever number you are getting, whenever you have started numbering in the double bond, CC double bond, you have to move to that direction where the double bond is present. So that is why the second direction, it is completely wrong. Fine. Now, if it is true, then which nomenclature should be correct? 3-bromo, because here bromine is should be mentioned alphabetically before chloro. B comes before C. So whatever is the position of Br, you have to mention it first. And in all the options, it is at first position. That is fine. But it is 3-bromo. Then it is 1-chloro and cyclohexene. It must be ending with in. Now, if it is true, then this is the correct option. But see, I will also draw the other possibilities and I will mention why it is not correct. Suppose I am starting the numbering from bromine. 1, 2, 3. So in this case, 1 is for Br, then 2 will be for CC double bond and 3 will be for Cl. Now see, here it is 1, 1, 3, but now it is 1, 2, 3, which is obviously lesser preference because of the rule of first point of difference. So that is why we have not started the numbering from bromine, but we are starting it from chloro. Okay, so this is not correct. Now one more structure we will see which is having some similarity with this one, but there is difference. Here CC double bond, its position is not same, and also bromine actually CC double bond position, there is we cannot say anything. Here at bromine and chlorine, now they are at 1 and 2 position. In the previous structure, their positions are 1 and 3, but now they are at 1 and 2 position. But the question is from which direction we should start. Suppose I am starting the numbering from bromine. So you cannot, once you have placed 1 here, you have to move towards the direction of double bond. You cannot move to the other direction. That is completely wrong when you have double bond. So it is 1, 2, 3, 4, 5 and 6. So 1 is for bromine, then 1 is also for double bond and 6 is for chlorine. That means it is 1, 1, 6. Now the other possibility we will also see. I am drawing the same structure, but now I will do the numbering in a different way. So suppose I am starting it here, then 2, then 3, 4, 5, 6. Now see, at 1 position there is CC double bond, at 2 position there is Br, at 3 position there is chloro. So we are getting 1, 2, 3, which is obviously getting less preference than 1, 1, 6. And you can also try the other directions if you are thinking any. You will always find that this will be the best option. So these are the two ways we can choose numbering, because there is a CC double bond. So either you start from this carbon of CC double bond or this carbon of CC double bond. So both we have tried and we have seen that 116 is better. Now what will be the name? Bromo will come first and its position is 1. Then chlorine is present at 6 position. Chloro, 1 bromo, 6 chloro. Just like before, there is no difference. Only These numbers are different. Otherwise, bromochloro, cyclohexene, there is no such change. Okay. So now we will see the nomenclature of benzene, substituted benzene compound. So it will be obviously aromatic. Benzene ring will be there, and there will be some substituents also. Now there is both, that is two types of nomenclature. Remember, there is a common name, there is also IUPAC name. So in aromatic compounds, the use of common names are very common. Okay, remember, IUPAC names are also used, but common names are very common here. Now regarding common versus IUPAC nomenclature, there are some common names which are accepted under IUPAC, but not all. So phenol, benzaldehyde, benzoic acid. These three common names, these are some of the common names that are retained in the IUPAC nomenclature. But other names such as toluene, styrene, naphthalene, phenanthrene, usually acceptable. But nowadays their uses are discouraged. So suppose when you are solving a problem, if it is that all the options are given common, then it is okay. But if you are seeing that one option is based on common, another option is based on IUPAC, then obviously go for IUPAC. If it is clearly mentioned in the structure of the, in the instruction of the question that choose the correct IUPAC name. So obviously you have to give preference to IUPAC. But suppose in the options all are mentioned with toluene. In that case, though toluene it is not encouraged under your IUPAC, but still you can write because of you don't have any other option. All the options there is toluene. So here you can see the three structure they are in red color, where there is weight substituents, CO2H and CHO. So only for these three, this is highly acceptable. That is completely acceptable under IUPAC. But if you look at the other structures, such as when there is methyl, it is toluene. When it is COCH3, it is acetophenone. These are actually sometimes it is used under IUPAC, but mostly it is discouraged. And there are two structures you can see where only methyl substituents are there, and they are in black color. So these names are not at all used. Only red ones are completely used. The green ones sometimes used, but not the black. Okay. Now here we will take one example so that we can understand the difference between common name and IUPAC name. So this is a compound which is normally known as TNT, trinitrotoluene, but that name is actually common name. Okay. Now see here, both common name, IUPAC name, both the names are mentioned. So when it is common name, it is the short form we use TNT, and it is 2,4,6 trinitrotoluene. Now if it is following this nomenclature, it is the numbering should be like this, then 3, then 4, 5 and 6. But that is for the common name. If you are following the IUPAC name, actually you have to follow the IUPAC name, because in IUPAC toluene is not encouraged. Okay. I will do the numbering in a different way. Now, if you are thinking why the same numbering cannot be used in IUPAC, that logic also we have to understand. So same structure I have drawn again. Now suppose you are following the same numbering for the IUPAC name, then what you will get? At one position there is methyl, then two position there is NO2, four position another NO2, third NO2, six position. So it is 1, 2, 4, 6. But suppose you are doing another numbering which is starting from 1, 2, 3, 4, 5. Now in this case you are getting at first numbering 1, then at 2 position methyl, then at 3 position another NO2, and at 5 position the third NO2. It is 1, 2, 3, 5. Now 1, 2, 3, 5 obviously will get preference compared to 1, 2, 4, 6 according to the rule of first point of difference. So that is why We will not consider the numbering that is followed in common name, but we will consider the 1, 2, 3, 5. You can also consider another way of numbering, but that is completely wrong. Suppose you are starting from this one, then you are moving to 3. If you do so, you will see that is also violating the rule of first point of difference. So that is why it is not correct. After 1, then next number you are getting 3. So it is not correct, right? 1, 2, 3, 5 will be correct. So that is why look at the IUPAC name 2-methyl, because M comes before N. So don't consider this try. It is just the total number of NO2. Methyl should be mentioned first, whatever its number. Because of the alphabetical order, it is 2-methyl, then 1, 3, 5, trinitro, and then benzene. So in this case, benzene, this term is retained because there is no OH or CO2H or CHO. Suppose if this type of groups are present, functional groups are present, then we will end with either phenol, benzoic acid or benzaldehyde. But when you have this type of substituents where you cannot use these terms that are accepted under IUPAC, then you have to end with benzene. Okay. Next rule is, instead of using numbers to indicate the substituents that we have just done, that is 1, 3, 5, whatever. Now sometimes ortho is mentioned, which is for 1, 2 substitution. Suppose you have benzene ring and at one position you have NO2 group, then 2 position you also have NO2 group. So you can say it is 1, 2 dinitrobenzene. That is according to the number, but you can also write it as orthonitrobenzene. So when you say orthonitrobenzene, it is actually 1, 2 dinitrobenzene. If these 2 positions are at 1, 3, then we use meta, and for 1, 4 it is para. And these 2 will be italics. So sometimes rather than writing the whole term ortho, we simply write O. So suppose I am writing ortho dinitro benzene. So you should write it like this, or simply write the whole term, that is ORTHO. But remember, these are not accepted by IUPAC, that you can use in common name. And this is for direct substitution, because this is the relative position of the 2 substituents. Now suppose one position there is methyl group, you can also write it as orthonitro. Rather than writing benzene, now you can write orthonitrotoluene, because with respect to CH3, the position of NO2 is ortho, or meta, sorry, not di, orthonitrotoluene or metanitrotoluene, like this. But remember, they are not accepted by IUPAC. When an aromatic compound contains 2 or more functional groups, suppose you have OH group and you have Br group, or if there is a substituent generating a common name. So different possibilities are there. So generating common name, all the common names we have seen in the previous slide. You just have to take the help of that particular table. It is named as a derivative of the compound with the principal functional group at position 1. So suppose you have OH group, you also have Br. You have to give preference to OH, and OH will be having number 1. It should be started from this principal functional group. So we will see some examples. Here we have CO2H group, so it should be starting from this carbon should be 1, 2, 3, 4. This is actually symmetrical. Whether you move left hand side, right hand, clockwise, anti-clockwise, it doesn't matter anything. So it is 4-nitrobenzoic acid. See, we have not used benzene because we are giving preference to this. NO2 is treated as substituents, which is at 4 position. We are ending it with benzoic acid because CO2H attached to benzene ring is benzoic acid. The next one is number 1. This is number 2. So NH2 group, it is treated as substituent. So it is 2 amino, and this whole portion that will be treated as phenol. Come to the next one. This is also phenol, and here numbering will be 1, you have to give number 1 to that carbon which is attached to OH, then 2, 3 and 4. If you are moving to this direction, it will violate the rule of first point of difference. So that is why I have moved in this direction. 1, 2, 3, 4. Methyl should be present after I. So I for iodo, I comes before M. So 4 iodo first, then 2 methyl phenol. Now in this case, though it is not encouraged under IUPAC, but as this generates a common name that is already mentioned in the previous slide, benzonitrile, and at 3 position there is acetyl group. Acetyl group is COCH3. This is one. There is one more example. Already numbering is done. We are giving 1 to this carbon because here CO2H group is attached. Then at 2 position there is bromine, 3 and 4. If you are moving from the other direction, it will violate the rule of first point of difference. And methyl and bromo, B will come before M. So that is why 2 bromo, 4 methyl benzoic acid. Again, we have phenol derivative and 2 bromo substituents. One is at 3rd position with respect to the position of OH. Another one is at 4th position, and it should be 3,4-dibromophenol. If you are again moving to this direction, the rule of first point of difference will not be maintained. Okay. Now, in some cases, it may happen that the groups that are present, that is the functional group that are present in the benzene ring, better we say simply groups, because now these groups that will be present, they are treated as substituent group. That is, they are not generating any common name. So what to do in that case? If you are not getting any common name based on the group that is present, then the various groups are arranged in alphabetical order. Just like we have seen, bromo comes before methyl, methyl comes before nitro, like this. But you always have to maintain Lewis-Rocan rule, which is the same rule. That is the rule of first point of difference. You can also use this term. So now we will see example. Here we have what type of substituents? We have OMe, we have Me, and we have Cl. Now none of this will generate common name. You can say that toluene is generated, but that is not accepted. And when OMe is attached to benzene, it is anisole, but that we do not accept under IUPAC. So that is why we will treat all these 3 substituents as a normal group, okay? And we will end the name with benzene because there is no common name generated. Now, if we are starting the numbering from this side, 1, 2, 3, and then 4. So what you are getting? You are getting 1, 2, 4. Another possibility is that if you are starting the numbering from methyl, then it will be 1, 3rd position Cl, 4th position OMe. Another possibility is that if you are starting the numbering from chloro, then it is 2, then 1 position chloro, then 2 position there is OMe group, and 3, 4, 5 position there will be methyl. Now according to the rule of first point of difference, we will accept this one, 1, 2, 4, which is preferred than 1, 3, 4, but 1, 2, 4 is also preferred than 1, 2, 5. According to the rule of first point of difference or Lewis-Rocan rule. So that is why this should be the correct numbering. So once you have done with Lewis-Rocan rule, next thing that you have to consider alphabetical order. So here methoxy, methyl, and chloro. So chloro will be given preference. So though it is 2 chloro, but still you should write it first. So it is 2 chloro, 1 methoxy. Now methoxy and methyl both are actually M, but see it is THO, it is THY. So that is why methoxy before methyl, and then simply end it with benzene without giving any gap. So why this numbering is preferred? It is based on Lewis-Rocan rule. Some more examples. We have bromo and chloro substituents, and whether you start from Cl, then bromine will be 3. If you start from bromine, chlorine will be 3. But we will give preference to So here lowest token rule is not applicable because in both cases it is 1313. So simply give preference to BR. So that is why it is given lowest number. Then the next one, here the correct numbering is this one, 1 to 4. Because if you try the other numbering, you will see it will violate. Suppose you are starting the numbering from NO2, then it will be 1, then 2, then 5. So it is 1 to 5, but here it is 1 to 4, which is preferred. So that is why this is not correct. And chloro will be before nitro. So 1 chloro, then 2 for dinitro. Again, we have 3 substituents. And see, whenever its position is like this, it is always 1 to 4. Because if you can also try the other numbering. Start from NO2, it will be 1, 2, 3, then 4. So it is 1, 3, 4 if you start from NO2. If you start from Cl, it will be 1 to 5. So 1 to 4 is obviously preferred. So that is why we have accepted it. But chloro should be at first, though its position is 2, it will always be first. Then methyl, then nitro. C, M, N. Okay. So 2 things you have to take care. Lowest locant. Once you have done that, next consider the alphabetical order. Now in some cases, this is interesting because some cases what may happen that the benzene ring with which suppose some substituents are there and that substituents is very long chain alkyl substituent. So in that case, benzene ring will be considered as if it is a substituent. Fine. So it will be as a substituent of the root containing the principal functional group. And the name of the benzene, when it is treated as substituent, it is C6H5 because see, this is benzene ring. Suppose it is substitute, it is attached to some chain or whatever. Now the total number of hydrogen actually here better I write benzene ring with double bonds because why this circle is given that we have not discussed yet. It is because of aromaticity that will be discussed separately. So see when it is substituent, this hydrogen is one hydrogen is less. So that is why it is C6H5, not C6H6. C6H6 means whole benzene ring, but now there is one hydrogen less. So it is C6H5, and when you will write the name, you have to write phenyl. The short form is pH. Okay. So suppose actually pH you can also use for any benzene compound. Suppose just take the example of phenol. How we write phenol? We simply put OH, right? You can also write the same molecule like PHOH. Or if there is NH2 group, you can write as PHNH2 or PHCH3. That is also fine. So pH is basically C6H5, nothing else. Okay. So here we will see these examples where you can see a chain attached to phenyl, and here numbering will be like this: 1, 2, 3, 4, 5, 6, 7, 8. So there is total 8 carbon. So that is why it is oct ending with N because there is no unsaturation, and this is treated as substituent which is present at 2 position. So that is why it is 2-phenyl octane, as if it is aliphatic compound, not aromatic compound. Second one also, here numbering will be starting from this side. Because if you are starting the numbering other way, if you follow, then the first substituent will get 3, then 4, then 5. So according to lowest locant, this is correct. So one position there is phenyl, but the bromo you have to mention first, alphabetical order, 2, 3 dibromo, 2 bromine substituents. And at one position, that is the first carbon, there is a phenyl substituent. So total 3 substituents, and the longest chain is total 5 carbon. So that is what is ending with pentane. But remember, when in benzene ring there is total 6 carbon. So when you have total number of carbon in the chain lesser than this, suppose 5 or 4, and though it may vary because the 5 or 4 carbon that you will have, which is lesser than 6, there may be some that is a chain Suppose the 5 carbon that is present, that may be present with some substituents. It is not simply long chain. So there may be very variation, but mostly if it is simple chain, when it is lesser than this 6 carbon, then mostly you can consider it as if it is aromatic compound. But when it is 6 carbon or 7 carbon, as you can see in these examples, phenyl should be the substitute. So see here, though it is 2 carbon chain which is attached to benzene, only 2 carbon, then normally if OH is not present, it should be treated as if ethyl substituent is present in benzene. Ethyl benzene should be the name. But though it is 2 carbon, but as there is a functional group OH present, so that is why now the preference is given to this 1,2 carbon chain, as if this is the main compound and this is treated as substitute. So that is why the name is 2-phenyl eth-all, but together we will write it as ethanol. So it is active derivative of ethanol. Ethanol is CH3 CH2OH. So though it is 2 carbon chain which is lesser than 6, but still because of presence of OH, we are using the name 2-phenyl ethanol. Now one more example we will discuss here, for which you can already see the IUPAC name, and that structure is this one. Suppose you have benzene ring, and with that, okay, again I have written this circle. Better we write it like this. Suppose with this we have CC double bond. Okay, so in this case, though this is correct IUPAC name, that means 3-phenyl 1-propene. Though it is 2 carbon, but because of CC double bond, we are giving it preference. Sorry, 1-propene, one more carbon will be there. So it is 3-phenyl 1-propene, 1, 2, 3. This should be treated as substituents, or it can also be called as 2-propenyl benzene. Now, if you consider this name as if we are focusing on this part, benzene, and this is treated as substituents, though these names are accepted, but preferred IUPAC name is pro-2-enyl benzene. So here we are ending with benzene. This is actually same as 2-propenyl benzene, but here it is written in a different way. Though this name is not wrong, but IUPAC preferred name is prop, then write 2 and then enyl, and then it is considered as if it is substituent in benzene. So here though CC double bond is present, but it is having not so much preference compared to H. So see, in the previous carbon, previous structure, though it is 2 carbon chain, but because of this OH, we are not giving preference to phenyl. But in this case, it is 3 carbon chain and there is CC double bond, not OH group or CO2H group. So that is why ultimately we are treating it as if there is some substituent in benzene ring, but other names are also there. And sometimes the benzyl group is present, which is similar to phenyl group, only difference is one CH2 is extra. So suppose we have benzene ring and you have not directly OH group is attached, but suppose there is CH2 group, then OH. Then this part is treated as PHCH2 because one carbon is extra. So the same molecule I can write in different way. You can also write it as BN, which is short form of benzyl, BNOH. If I am writing PHOH, that means OH is directly attached to benzene ring. If I am writing BNOH, that means it is attached after one CH2. Now, when it is like this, the name will be benzyl alcohol. And suppose if it is PHCH2Cl, it will be benzyl chloride. Okay, so this group is benzyl, just like phenyl. Now one CH2 extra and the name is changed to benzyl. And compounds, nomenclature for this benzyl group based compounds very similar to the phenyl group compounds. Okay, so we will discuss some question based on the nomenclature of aromatic compounds in the next class. We are ending the session here. Thank you for listening.